Hello, thank you so much for your time and thanks for the click. My name is Darren Fee. Today's presentation is all about integration by substitution. And because we want you to understand the concept really well, we have divided it into 4 parts. Now the first part, we look at the basic integration for beginners. And then the second part, we are treating algebraic substitutions. And then the third part, we are looking at integration using exponential functions. Then the last part will deal with integration using trigonometric substitution. Alright, so let's look at some important techniques when it comes to integration by substitution. Now the first step that you need to know is that you have to find u variable in the given function. So the function that you are going to integrate, it doesn't fit into the standard integration that we are familiar with. So you are going to pick one of the functions as your u. Now this is the most important part of integration by substitution. Why? The most important aspect of this technique is your choice of u, because the derivative of u must be able to cancel the x in the other function. So this is what makes this technique very important. Now, which one are we going to choose as our u? The technique here is that whatever function you pick as u, is that when you find the derivative of the u, it should be able to cancel the x in the other function. Then the step 2, after identifying the u variable, find the u. So you are now going to differentiate the du that you have picked. And then the last step is that if the selected u variable contains x, then find du dx. And then the most important thing, after finding your du dx, you must always remember to make dx the subject. So this is very important. Now let's go to the questions. Now if you look at this is the basic standard of integration that we are talking about. And so we know, for example, that the integral of 1 over x is going to give us ln absolute value of x. These are standard integration that we are going to use. And so I encourage you to make sure that you know this off it. Now this you must know, so that when it comes to the working, it will be easy. So for example, the integral of cos x is going to give us sin x. Now you see plus c because this is indefinite integral. Then the integral of sin x dx is going to give us negative cos x dx, and we have to know this. So this is going to be the foundation for our presentation. Now let's go into the work itself. By the end of this presentation in part 2, you should be able to determine the integral of cos x into brackets 3x plus 7 dx. And so we want to go into this. How do we use integration by substitution to solve this algebra? Now let's go to our first question. Okay, so let's solve our first example. Determine the integral of cos into bracket 3x plus 7 dx. Now you should realize that this is not a standard integral as we saw previously. Now we know, for example, that the integral of cos x is going to give us sin x. But here, this is not x, this is 3x plus 7. So we are going to now use the substitution method in solving it. And so let's now move. So note that because cos into bracket 3x plus 7 dx is not a standard integral, we have to represent this with a variable called u. And so we are saying that let u is equal to bracket 3x plus 7. Now remember from the technique that we learned earlier, we said anytime you pick your u, you are now going to differentiate this u with respect to the x. And so we now move on to differentiate u. So du dx. Now when we differentiate 3x, we are going to get 3. Now we said that after getting the du dx, the next thing that you need to do is to find the x, meaning we want to make the x the subject. And so from what we see here, how do we make the x the subject? It's a matter of just cross multiplying. So this multiply, and then you are getting dx is equal to du over 3. Now notice that du over 3 is the same as 1 over 3 du. And so now we have succeeded in getting our u. And after getting the u, you must also go ahead to find the derivative of u. And then after getting its derivative, you must always remember to make the x the subject. The reason is that we want to get rid of every x in the original question. And so now let's go ahead and substitute these values into the original question. Now by doing so, the original question, in place of 3x plus 7, now we are having u there. Remember, this cos is still there. We have not changed the cos. But in place of 3x plus 7, we are having u. And then in place of the dx, we know now that dx is equal to 1 over 3 du. So in place of the dx, we now have 1 over 3 du. So that is what we call the integration by substitution. Now you can see clearly that we can factorize the 1 over 3 out stage. So having it, we now move on. Now you can see here that we have factorized the 1 over 3 here out. So it is now coming outside the integral sign. So we now have 1 over 3 integral of cos u dx. Now you see, this now makes it simple. What we learned earlier, we saw that the integral of cos x is going to give us sine x. So it means the integral of cos u is simply going to give us sine u. And so when we continue, now you see that the integral for cos u is giving us sine u. Now remember, this 1 over 3 is what we see here. And because this is indefinite integral, you need to introduce the constant. So we have the plus c. And so we continue. And now remember that in the original question, there was no u. The original question, it was 3x plus 7. We decided to make it simple for us to solve. We decided to replace this with the u. So now that we have finished integrating the original question, it is wise for us to return the actual value. And so rewrite u as 3x plus 7. That means whatever you see u, you need to bring this one there. And so when we come down, obviously we have now replaced this u with the 3x plus 7. And so this is the simple way of using the integration by substitution. So basically, the integral of cos x into bracket 3x plus 7 dx is giving us 1/3 sine into bracket 3x plus 7. And question 1, we are done. Thank you. Let's move on to question 2. Now the next question says, find the integral of bracket 2x minus 5 bracket close to the power 7 dx. Now this is interesting. Now why is it interesting? It simply means that the 2x minus 5 is multiplying itself 7 times. And then each term should be integrated. And that is going to be a very long process. So imagining multiplying this 7 times. So 2x minus 7 times 2x minus 5 times 2x minus 5, 7 times. And then each term is going to be integrated. Now we can simply do this by using the substitution. How? In place of the 2x minus 5, we want to place u there. And it will make it so simple. So when you go ahead, you see that we are saying that wherever you see 2x minus 5, let's put u there. So we have let u is equal to 2x minus 5. And remember, once you bring the u, you must always remember to differentiate the u. Now because we have x in the function, we are differentiating the u with respect to this x. That's why you see we then differentiate u with respect to the x. So let's go. Now du dx is going, so the differential of 2x is going to give us 2. So now du dx is equal to 2. What you do next is to make dx the subject. So at all times, after differentiating the u with respect to whatever variable you have in the function, so here we have x in the function, that is why we differentiated u with respect to x. And the next thing to do is to make dx the subject. And so making dx the subject, we are actually getting du over 2. And this is very important, and that will help us in our presentation. Now earlier we represented 2x minus 5 by u. We said that whatever you see 2x minus 5, you must put u there. And so this original question now becomes the integral of u to the power 7. And now notice that wherever you see dx, you are now going to write du over 2 there. That is why we ask you to make dx the subject. And so we want to get rid of x completely from this. And so you see du over 2 here. That means it is replacing the dx. Alright, so now that we have this, we can now move on and then solve our question. So what do we see here? Now du over 2, we simply factorize the 1 over 2 out. And so when we come here, we have 1 over 2 coming outside the integral sign. Remember, there is 1 here and then we have 2. So that is the factorization. Now when that number comes out, we are now left with the integral of u exponent 7 du. And now we want to integrate this using normal integration. And how do we do normal integration? You add 1 to the exponent, and then whatever you get, you divide by 8. So this 1 over 2 is what we see here. And then u to the power 7. Now 7 plus 1 will give us 8. And so this same 8 is what we see here. And this is basic integration that we know, plus c. So we are now done with it. But you can see clearly that we can go ahead and do some multiplication. So let's now move on and see what happens next. So look at it. You can see that here these 2 can multiply this 8. Okay, and so let's move on and see. So obviously we have 1 at the top, and then 2 times this 8 will give us 16. So we are having 1 over 16 u to the power 8 plus c. But this is the integration that we are getting. But remember, in the original question, there was no u in the original question. And so we need to return the actual value here. And so moving on, we want to replace u with 2x minus 5, because that was what is in the original question. And so this is the final integration. All we do next is that whatever you see u, put 2x minus 5 there, and then the question is done. So this is how easy it is to use integration by substitution. So you can see here that in place of this u, now we are having 2x minus 5. Obviously, because it was indefinite integral, there's a need for us to introduce our constant, and that we are done for the second question. Perhaps the next question will help us understand things better. So what's the next question? Determine the integral of 2x over the root of brackets 4x squared minus 1 dx. And this is interesting. So here the question is, which value should I pick as my u? This is the key thing, and that is why I want you to see this. Now if you go back to the technique, we say that whichever function you pick as your u, when you differentiate, it should be able to cancel out the x. So for example, if I pick 2x as my u and I differentiate 2x, I am going to get 2. Now if I get 2, that 2 cannot cancel the x I have here. On the other hand, if I pick 4x squared minus 1 as my u, When I differentiate 4x squared, I am going to get 8x, as you see here. And this 8x, the x here can easily cancel the x here. That is why the choice of u is always important. So here, the best way to solve is to pick this one as my u. So I say let u is equal to 4x minus 1. And then obviously once I have my u, and then in the u I see x in it. So I am going to differentiate u with respect to x. And that gives us du dx is equal to 8x. And we have said that whenever you finish differentiating du dx, always remember to make x the subject. So here we now isolate the x. So making the x the subject, we get dx is equal to du over 8. And then we now move on to the original question. And okay, so at this point, this is the original question given to us. Now you can see that the 2x has not been changed. The same 2x, we have it here. And then we said that in place of the bracket 4x squared minus 1, we replace this with u. And so in place of this, then we place the u there. And now the dx, we have determined dx to be du over 8. So in place of dx, we are going to put du over 8 there. And that is why we have du over 8 here. Now, the reason we picked this as our u is that 8 derivative should be able to cancel this x. So you can see clearly that this x can cancel this x. And then 2 goes into 2, 1. And 2 goes into 8 4 times. And so the 1 here and then the 4 here will be factorized. And so you bring that one outside the integral sign. So when we come to the left and the right hand side, you can see 1 over 4 here. So that explains how we got it. So the blue here, x cancelled x, 2 into 2 is 1, and then 2 into 8 is 4. And then we have the integral, obviously. So if the whole of this is out, what is left is 1. So we have 1 over the root of u du. Okay, so that is how easy it is for you to be using the integration by substitution. So now let's now move on. Now don't forget that the root of u is the same as u exponent 1 over 2. So what we have done here is to change this one into a simpler form. So root u is the same as u exponent 1 over 2. And now what we have to do now is this is just like finding the inverse. Okay, so this is the same as u exponent negative 1 over 2. Now that you see the blue sign here. Now the blue here is an indication of a negative sign. Okay, so let's now go back to change the pen and understand it better. Now you notice that when you have 1 divided by a, 1 divided by a, now this happens to be the inverse. So this is the same as a raised to the power negative 1. It's the same thing. So why is it the same thing? It simply means if you have 1 over u exponent 1 over 2, this is the same as u raised to the power negative 1 over 2 du. Okay, now let's move on to the presentation by changing the cursor. So with that, it is now clear that we are now integrating u exponent minus 1 over 2 du. And the normal integration that we know, the basics, you are adding 1 to the exponent. So we have u exponent minus 1 over 2 plus 1. And then whatever you have at the top, have the same thing down here. Okay, so when you add 1 to minus half, you are actually getting half. And so here to adding 1 to minus half, we are getting half. Now this also gets more exciting. Remember, you must always introduce your constants because we are dealing with indefinite integral. Now here some form of work was done If you are an advanced math student, you understand this. But if you are not, I'll take time to explain this concept to you in a language that you understand. Now, how do we explain this? Now you can see clear that these two, okay, these two here should be able to cancel the 4. So the 2 goes into 4 2 times. So we have the 2 here. But this one still remain as the 1 here. So it has no change. And now you also understand from what we did previously here that the root of u is the same as u raised to the power 1 over 2. So we are now reverting u exponent 1 over 2 back to its original form. And so that's why we have the root of u here, and then plus c. But remember, in the original question there was no u. We replace u with something. So once you are done with your integration, you need to go back and bring the original value or function that was given in the question. So going back, we want to replace u is equal to 4x squared minus 1 into this. So wherever I see u, I will bring 4x squared minus 1 there, and finally we are getting this answer. And so this is how to use integration by substitution when you are dealing with algebraic functions. Thank you so much for your time. My name is Darlin Fee, and I hope this video is going to make an impact. And please make sure you comment and then give us your subscription. Thank you. Have a good day.